is imperceptible to us because we are only changing by a millionth of a proton as the gravitational wave goes by, but you build a good enough instrument, you can see them. All right, so that's everything. So I'm going to take a few second pause and just ask, I have a couple of pictures of my journey in science. Anyone want to hear it, or should I stop? All right, you want to hear it. Okay, let me just tell you a little bit about that. So that's the end of the science. I'll take questions on anything, but let me tell you a little bit about this so you can then decide. So my journey in science began, as Natiha told you. So I was a student here in Pakistan. When I was a student in school, I had two wonderful experiences. One was I learned to repair bicycles. And that's going to be an important part of my story. So if you guys like working with your hands, tinker. It's really important. And then the second thing was I had a chemistry teacher. I actually was not very fond of chemistry, but I was very fond of my chemistry teacher. And he used to let me go after hours to the lab and make chemistry concoctions in the lab. And his story was that he was from Sri Lanka, and he had been part of the student rebellion there, so he knew how to do interesting things like make Molotov cocktails and firecrackers and stuff. And he gave me a little bit of freedom. So to the teachers in the room, take some risk. Okay. So that's how it started. Anybody recognize these two people? So this is my friend Madiha and I when we were in high school. So that was that was in Karachi. Then came for me, the next big thing was the lesson that it's much more fun to chase unknowns than to just work on known problems. And that came to me when I first started working in a lab as an undergraduate. So I was an undergraduate at Wellesley College in the US. And I had my first job working in a research lab. And for the first time, I understood that there are questions out there that no one knows the answer to. Not the problems that we solve in our homeworks, which are people that most of the time we know the answer to, really unknowns. And that was something that I could never, I never looked back again. That was the most exciting thing. So I started working in a lab, trying to answer questions that no one else knew the answer to, and knowing full well that I may never know the answers to either, but you still had to ask. So that's how I got that. That's me sleeping outside in a couch outside the lab. I used to work in the lab all hours of the day in college. Then I had this crazy encounter with Ray Weiss. You've heard about him. He was the Nobel laureate, the inventor of the LIGO experiment. And that happened for me when I started graduate school at MIT. And so this was 1991. And he was the first person who told me, well, there's this measurement I want to do. It's 10 to the minus 18 meters. It's 1,000 times the size of a proton, and we're going to do it. And I thought he was insane. I really did. But then the more I thought about it, I realized that even if it was insane, it would be really important to try. So that's the other thing. To the students in the room, take some risk. Okay? So I did that, and then... Oh, yeah, absolutely. You want to do it now? Yeah, okay, come. Yeah, go ahead. You have the mic. All right, so... physics and math and engineering has not been completely fair to women. I've had a fantastic career, and part of the work that I do next is to fix that. Okay, so that's yeah, thank you. Not that these people weren't wonderful; it was just not enough women there. This is a picture of me at LIGO, at the LIGO Observatory in Washington when it was threatened by a big forest fire. And so I show this picture because I want to show you that sometimes there's also adventure in science. So we were literally at some point, this was the last 10 minutes we were up there before we were evacuated from the site. And then the remarkable thing was that the observatory, because it's a big concrete tube that's going for 4 kilometers in the desert, it formed the fire break line. So the fire was stopped by the observatory and didn't reach the city. So science can help. This is me a few years later working with my first students, so now I've gone from being student to teacher in the lab. And then this is me and Ray Weiss on the morning that the Nobel Prize was announced, and what the picture doesn't show is we're both crying. So, And then I want to also say, for those who sometimes ask, can you really mix a career in science with being a normal person? The answer is yes. So I have 2 kids and a family, and this is my older son working with Ray Weiss in a machine shop. We were doing science in the lab at the time. He was about 5 then. He's 16 now. So you can mix that too. So I'm just going to show you a series of pictures. Notice that the number of women gets to be larger. So this was my group in 1993, and again, I was the only girl there. And now then in 2015, at the time of the discovery, we're now 4 of us. So, you know, and then this is me in the lab in 2013. With a big discovery, you get to do some fun things. This is me doing the gravitational wave dance with Neil deGrasse Tyson. So let me, you want to see the gravitational wave dance, right? I knew you want to. Okay. All right. Yeah. Okay. So I already told you what a gravitational wave does. If it comes through me, it's making me longer and shorter, right? It's changing my. What I didn't tell you is that it's done in a cross shape. So if my vertical direction is getting longer, my horizontal section is getting shorter. So it's sort of doing this. And so the gravitational wave dance is here I am, and the gravitational wave is going right through me. And so there's a piece of me, so shorter, longer, shorter, longer. That's the gravitational wave dance. You guys want to do it? Oh, come on. You're making me dance alone, really. Okay, and then this is another favorite picture of mine. This was taken on the morning that we announced the gravitational wave discovery to the world. And I really like this picture because a photographer caught it, and it was a very intimate moment between me and my son. And he was sitting in the front row as we were making the announcement, and he was bored, and I was just saying, I got you, kid. And so that was okay. So, and then the very last thing, this is, I got to have a trip to Stockholm for it. This is at the Nobel ceremonies in 2017. And I'll stop there. That's my story. Oh. No, come on. Just ask me questions. I talked for longer than I planned, but I really want to hear from you. Yes. What do I believe the future of my work is? Fantastic question. So I've tried to not be very technical, but my role in this whole thing has been always from the start, I'm asking how do you make this gravitational detector more sensitive? Why more sensitive? You have a more sensitive detector, you can see fainter objects, and you can see farther away. And we want to be able to map out these gravitational wave events in the universe to the edge of the universe. And we happen to know where the edge of the universe is. So that's the thing. So what I work on actually is on how do you make a measurement that's already at the precision of 10 to the minus, by now, 19 meters. How do you get to 10 to the minus 20, 21, etc.? And you ask me, well, what is that? I'm only going to say a few words, and this is only for the experts. It turns out when you make a measurement of that precision, the part of nature that gets in the way is not that the Earth is moving and it's seismic and waves. That's all there, but we know we have control systems, we control all of that. The fundamental part of nature that gets in the way is quantum mechanics, which says you cannot make a measurement with arbitrary precision. And so all of my work is in tricking quantum mechanics. You can never change the laws of physics, but you can trick them, and that's what we do. So, yeah.
My question is how we know that the universe came from a point of infinite energy, right? So.
Yes. So
how it originated from it?
Yeah. So the question is, how do we know that the universe originated in the Big Bang? It's a really good question, and I would say we don't know. We don't have any better alternative, but what we do know is what we see of the universe today, and by making measurements that we have from our telescopes, all different kinds of telescopes, we also know how to play the movie backwards. And when you play the movie backwards, what you find is that all of matter and energy seems to have been concentrated into a single point. It's called a singularity, a mathematical term, from which the universe started. And then you say, well, why does it have to be a Big Bang? Because we have observations that the universe had a period of inflation, it's called. It's a very rapid expansion. So if you look at the story of the universe, the best that we know it, what the data will tell us is that the universe began, with an explosion from a single point, And then there was and all of matter and energy was contained in that. And then it expanded. So you can think, here's an experiment you all can do. Take a balloon, any balloon, and draw some dots on it, okay? So, and then start to inflate the balloon. So the dots are stars and galaxies. And as you inflate the balloon, that's the universe expanding, and the distances between the stars and galaxies gets bigger and bigger. And that's that's what we believe was the origin of the universe. And we have quite a bit of evidence for the movie played backwards.